Okay, we've got a specific request here. We don't just want to simplify this to be anything, and we want to rewrite this so that it has no fractions. We don't want any fractions. We want it to be very linear. So that is our goal. Well, take a look at this thing here. It doesn't give us a whole lot to start with. If I write it out, 1 over 1 plus cosine of x. I mean, changing cosine to be 1 over secant really doesn't get me anywhere. That's creating more fractions, and I've got this addition here, but it's not Pythagorean because it's not cosine squared. Well, after you play with it, you may have stumbled upon this, but it's come up in previous examples. We can use the conjugate of 1 plus cosine of x. We can multiply the top and the bottom by the conjugate, 1 minus cosine of x. And this can sometimes be a really helpful thing to create a Pythagorean identity situation, because we know when we multiply times the conjugate, we don't have that middle term. The middle term would essentially cancel out. We know that the bottom would be 1 minus cosine squared x. You know that if you've done a lot of factoring, dealt with that difference of squares a lot. We know how that all shakes out. In the top, 1 times that, well, that's simply just 1 minus cosine of x. So we're starting to get somewhere. Now let me backtrack for a second. Some of you are probably still thinking, way back here at the beginning, why could we not just do 1 over 1 plus 1 over cosine of x? You're thinking, why can't we do that? This is not true. We can't break it up like this. We can't break it up to be 1 over 1 plus 1 over cosine x. This doesn't work. This is bad. All right, let's example, okay? 1 over 2 plus 8. Okay, we know how this works. 1 over 2 plus 8, that would be 1 over 10. Well, what happens if we break it up to be 1/2 plus 1/8? Well, 1/2 is 0.5, 1/8 is 0.125. That gives us 0.625 if we were to break it up like that. Well, what we know is really that doesn't equal that. We know it really equals 1/10, which is really 0.1. Notice how these are not the same thing. We can't break it up if we have the addition on the bottom. We can't do that. So that's why we did not go down this road. This is all bad. That doesn't work that way. We can't break it up like that. That's what the very simple concepts that we were taught years ago mean. Okay, so we have to try to get one term in the denominator so we can break it up over that. We can divide each piece of the numerator by the one piece of the denominator. So that's where we've gotten so far. Ugh. All right, rewind that back. Okay, we're trying to create a Pythagorean identity situation because we saw we had 1 plus cosine of x. It just seemed like we were going in that direction. That was why I got here. I multiplied by the conjugate. If we were to multiply these things out, things cancel out to leave us with 1 minus cosine squared x. And so that's where we're at. 1 minus cosine squared x by our Pythagorean identity is just sine squared x. It works out. Go back, look at your Pythagorean identity. That would be true. So on the top, we have 1 minus cosine x. Now we have one term in our denominator, so we can break it up. This is equal to 1 over sine squared of x minus cosine of x over sine squared x. We can divide each term of the numerator by the one term of the denominator. Now this is still fractions. So right here, 1 over sine squared of x, we know by the reciprocal identity, we know that would be cosecant squared of x. And I'm going to actually write this as the product of 1 over sine of x times cosine of x over sine of x. So if I break it up to be the product of those two things, I know 1 over sine of x is cosecant. So I have another cosecant there. And cosine of x over sine of x is cotangent. And so those are multiplying together. We have made this an expression that does not involve a fraction. And that was our goal. So here we are.